Still looking at definite integrals here. This time I'm looking at the area enclosed by the curve. Now I'll show you what I mean when I say area enclosed by the curve. Look at this particular function, y equals x cubed minus 4x. It's a cubic. Now if I take my graphics calculator and I type it in, y equals x cubed minus 4x, I can draw it. And you can see that it's a cubic that goes up here like this, down here like this, and through here. Now the area enclosed, what we mean by that is the area cut off by the x-axis and the function. So the area in here and also the area in here. I'm just going to draw a quick sketch of that. Goes up, let's just take another look. Up, cuts through the origin, comes up again. Now when we say area enclosed by the function, we mean this area and this area. Now there's a bit of an issue here because if you were to find the definite integral between this point, which is -2, and you can use your calculator to find that using your roots, and this area, which is +2. Now if we were to do the integral between 2 and -2, this part of it would be given as a negative area, this part of it would be given as a positive area, and the whole sort of thing would cancel each other out, and we'd end up with an answer close to 0. But we can clearly see that our area isn't close to 0. There's a big area here and a big area here. So what we actually need to do is do it in 2 stages. We need to find the integral between this point and this point, and we need to find the integral between this point and this point. Okay, so let's do that now. So the area enclosed is equal to the integral of x cubed minus 4x between 0 and -2 plus the integral of x cubed minus 4x between 2 and 0. So let's take a look at what I've just done there. I found the integral between here and here, and I found the integral between here and here. Now when I do this one, it's going to give me a negative answer. So I'm going to be a bit clever here, and I'm going to use those 2 lines here. Now those 2 lines are going to give me my absolute value of that. It's just going to give me this as a positive number. It's an easy way around, but you'll see what happens as we move along here. Okay, I'm just going to do a little bit of integrating here, and I'll come back to you in a minute. Okay, so hopefully you can see what I've done here. I've integrated x cubed minus 4x, that's x to the 4 over 4 minus 2x squared, between 0 and -2. And I just need to do the other half of that, plus the absolute value of x to the 4 on 4 minus 2x squared between 2 and 0. And we want the absolute value of that. You can see these things start to get really bloated. They start to really blow out here. Now we need to do this between 0 and -2. So we need to sub 0 into that, and then we need to sub -2 into that and subtract 1 from the other. So it gets quite complicated. Okay, so this is this bit here. You can see I've substituted 0 into the equation, and that's all going to end up being 0 in the end. And I've also substituted -2 into the equation, and I'm subtracting 1 from the other. Okay, like I said, it gets quite complicated and quite difficult to keep a hold of. Let's do the second half while I'm at it. I'm going to add the absolute value of, and then I'm going to do that bit the same way that I just did that bit. Okay, so you can see that I've done the same thing with this half here. The absolute value of, and I've substituted 2 into my equation. 2 to the 4 over 4 minus 2 to the 2 squared. And then again, I've substituted 0 into the equation. And eventually that'll all be 0. Alright, so I can start trying to sort of organize some of this stuff. This function with 0 in it, 0 to the 4 over 4, that's 0. Minus 2 to the 0 squared, that's 0. So that whole bit here is going to be 0. Okay, so that's pretty straightforward so far. Minus -2 to the 4 over 4 minus 2 to the -2 squared. That's going to end up being something. Let's figure that one out. Now this bit here is going to end up being 4. and this bit here is going to end up being negative 2 squared is 4 times 2 is 8. That's going to be negative 8. So this first half here is 0 minus 4 minus 8. And I'll just do my second half here. Now this back half is pretty simple. This whole function here is going to be a 0. And then I just need to deal with this half here. Now you can see there's a nice bit of symmetry here. 2 to the 4 is 16 divided by 4. So that's going to be 4. And then I'm subtracting. 2 squared is 4 times 2 is 8. So I'm subtracting 8. And don't forget we're absolute valuing that. Okay, so 0 minus 4 minus 8. So 4 minus 8 is minus 4. And I'm doing 0 minus minus 4. So 0 minus minus 4 is 4. And then here, I'm doing the absolute value of 4 minus 8. This minus 0 obviously isn't going to come into play. So 4 minus 8 is going to be minus 4. So plus minus 4, but don't forget absolute value. So if this is minus 4, it's actually positive 4. So 4 plus 4, finally 8. So the answer to this whole question, the area of this bit here was 4, the area of this bit here was 4, we add them together, area equals 8. The real takeaway from here is if you're finding the area between two values and the function goes up and down, as you can see here, then you need to break it into its sections, break it into its roots or its x-intercepts, and then do each section separately. Very, very complicated working, as you can see here. A lot of opportunities to make some mistakes, so make sure you move through these fairly slowly and methodically. And practice, practice, practice. All right, thanks guys.